So let's do a second part to this challenge. I'm calling this the Paren bracket curly balance challenge. I need to change that. That should be a T, not a Y. A bracket. What we want to do for this challenge is it's very much the same idea, but we want to be able to detect of strings that have more than just parens in them. So what if we had something that was like here, let me start that again. What if we had something that was like a function call with the parenthesis, with an array, with an index in there, and an object with a name that had maybe even an array of things. It's a bit more complicated. We have, for one, characters that we want to ignore. So we don't care about an F or an O and an O. For this one, it's really equivalent to just asking if the parenthesis and the bracket and the curly brace and the bracket and the curly brace and that parenthesis, if these are all balanced. And you can see that we're going to use the exact same strategy of if we have our stack over here, first we're going to fill it up with a parenthesis and an open bracket. And now when we hit this closing bracket, we want to compare it to what's on top of the stack. If they match, we should pop that out. And then if we ever see something that's opening again, here's an opening curly brace, so we should put that on our stack. We see an opening bracket, we should put that on our stack. When we reach a closing bracket, we can look at the top of the stack and see that those match, so that is no longer in there. Now we see a closing curly brace. We see that this closing curly matches this closing curly, so we can delete that or pop it off of the stack. And now the stack only has the opening parenthesis, and when we compare it to the closing parenthesis, we can see that those are a match, and we are able to delete it. That leaves our stack totally empty, and so this is true. It is balanced. And we could try the same thing for something that is not balanced. So let's draw one that would not be balanced. Let's say we had very much the same thing. Opening paren, opening bracket, closing bracket, opening curly, and maybe a opening bracket, a closing curly, and a closing parenthesis. So if we follow the same logic, we're going to have a stack over here. And as we move through this string, we're going to add an opening paren, an opening bracket. So we've got the opening paren, the opening bracket. Now we're looking at the closing bracket. The closing bracket matches the opening bracket, so that one is deleted. Now we're looking at the opening curly brace. And since it's an opening thing, we can just put it in there. And now we're looking at the opening bracket. So we can put an opening bracket in there. And now we actually have an error where if we hit the closing curly brace, we see it doesn't match that. And because this does not match, this should all return false. So this is a very similar technique to the first problem, but what you're going to need to modify in this challenge is ignore any letter that is not an opening character or a closing character, and you have to take extra care to make sure that you match a parenthesis to a parenthesis, and match a bracket to a bracket, and match a curly brace to a curly brace. Good luck. All right, let's see how to solve this one. So I've made some test cases. This is the same thing we had before, the foo, AAI, bar, all of that. And down here I have one where we have these parentheses match here. We have an extra parenthesis here. Basically, what I'm trying to simulate here is we forgot to close another parenthesis or something. So it might look, I think this is balanced now. This is balanced. That would not be balanced. Here, maybe we should do it like this. There we go. I think that's better. I feel like this is kind of a common mistake. If we were trying to surround these in parentheses and then surround all this in parentheses to multiply it by the 3, sometimes it's just, well, it's like if we go up here, if I delete this parenthesis here in the actual code, I get the syntax highlighter telling me that something is wrong. So here it says it expected a comma, and it expected a comma because we're missing a parenthesis here. So the program that we're writing right now is actually something that could be used in something like a syntax highlighter. So let's see if I properly did not do this correctly. Yeah, so this one should not be true. So how do we deal with the identification of the different characters? Here's how I like to do it. I like to make a constant of opening where I say we have a parenthesis, a curly brace, and a bracket. And then I like to make a mirror of that, which is a string with all of the closing characters. So now what we can do is we can use this string here to say if the opening includes this letter, we can push that letter onto the stack. Now we can say else if the closing includes that letter. Well, one thing we can do is we can say if we ever see a closing character, and if the stack.length is 0, we can immediately return false. And I'm going to put a comment there that says each closing character must match an opening character. Must have a matching opening character. So if the stack is empty and we see a closing character, we know that's a problem. Otherwise, why don't we go ahead and say we'll get a reference to what's on top of the stack. We will peek at the stack. And now we want to see if these things match each other. So we could say something like if the top equals a opening parenthesis and the letter equals a closing parenthesis, and we could actually do that for every one of these things manually. I've got 4 signs. So we could do that for each of these things. So if these things ever match, well, we can say stack.pop off the thing on top because we've found a letter, which is a closing, and it matches what's on top of the stack, and it matches like a parenthesis matches a parenthesis, a curly brace matches the curly, the bracket matches the bracket. And if there was ever something like that that was not true, we could return false. So I do believe this works. Yes, it does. But I find this code here to be a little bit annoying to write. So let's do something a little bit better. Let's say what I want to do is I wrote these in the same order for a reason. First of all, I do think it's great. This is a good trick to do whenever you're dealing with characters. You can put them all in a string, and then if you have access to a function like includes, it makes it really easy to test for a group of characters. If you ever want to test if something is just even in the alphabet, this is a great trick. You can make a constant called alphabet, and you can ask if something is a letter in the alphabet real easily. Well, what I really want to do over here is I want to say, how about we say if opening dot index of the thing on top equals closing index of the letter that we're looking at. So this actually does the exact same logic. This logic is way more spelt out, but this will do the same thing. We're saying if this top thing has an index that is inside the opening, and if that opening index matches the letter in the closing index. And we already have a guarantee that the closing, the letter we're looking at, it is in the closing. So we don't actually have to worry about something like the letter F returning a -1, and this thing being like a bracket and it returning a -1, because we're guaranteed that one of these is actually in here. But I just want to show you that trick. So yeah, if we make these two strings up here for the opening and the closing, and we check the index of each of them, and we make sure to arrange these so that they match, it's possible to save ourselves writing a little bit of hard-coded logic there. So let's run this again, make sure it works, and there we go. So this is actually a pretty powerful function. Notice that the simplicity of the stack is fantastic. The only thing we need to use on the stack is the push and the pop and looking at what's on top with the peek. And we're actually able to solve a rather interesting programming problem. In fact, if we tried to solve this with our knowledge of maybe just strings and arrays and a for loop, it might have been a little bit harder. We would have had to like make a while loop where something moves in from the left and finds a parenthesis, and then we have something that moves in from the right and finds a matching parenthesis, and it keeps going further and further in. And even that would be hard, because if we tried to do that, see even here, like the opening bracket it doesn't match up immediately if we just had a simple while loop coming from the other direction. So the stack is, it's a very simple data structure, but it is awfully useful.